Okay, we're looking at number 5 and looking at some of the homework that was assigned. So this is all about solving right angle triangles. It's all about using our SOHCAHTOA and figuring out which ones should we be using and where. So let's take a look at our first instance here. So first one, we're going to label this triangle. Here's our angle of interest. Here's our hypotenuse. Here's our opposite. Here's our adjacent. And let's start this up. So what do we need? Well, if we take a look, adjacent is what we need, hypotenuse is what we have. Which one uses adjacent hypotenuse? Well, those ones right there. So we're going to have to use our cosine here. So we're going to have cosine 33 equals our adjacent, which is x, divided by our hypotenuse, which is 12.2. Multiply that up, and we get 12.2 times cos 33. Remember, this is not an angle. We're not solving for an angle, we're solving for a side. So we're not going to hit our shift key, and we get that equals x. So x is going to equal 10.23. Okay, this next one here uses the words angle of elevation. Angle of elevation means if you are on the ground, angle of elevation means we are looking up. So that's kind of how this works. So here, if here's our triangle, it says the angle of elevation to the top of the turbine is 87 degrees. So we're looking up almost at a 90-degree angle. Okay, now it says from a point 4.5 meters. So it's 4.5 meters. We want to figure out how tall is this thing. So hopefully it's pretty tall. Wind turbines tend to be pretty tall, so we should get a pretty large x value here. So let's label our triangle. We have our hypotenuse, we have our opposite, we have our adjacent. So let's make this happen. So what do we need to use? Opposite adjacent means we need to use tan. So if you look at SOHCAHTOA, tan 87 equals our opposite, which is x, over our adjacent, which is 4.5. And now we're just going to multiply that up. We get x equals 4.5 times tan 87. And let's see what that gives us. 4.5 times tan 87. It does give us a big value. It gives us 85.87. Okay, so from a point 9.3 meters from the base of a billboard. So let's draw 9.3. Here's our billboard. It says the angle of elevation is 28, and we just learned about that. And we want to figure out how tall this thing is. So almost the exact same question. You're going to follow the exact same recipe, and here's how we do it. Tan 28 equals opposite, which is x, over adjacent, which is 9.3. Bring that up, 9.3 times tan 28 is what's going to make this happen for us. And this is going to give us a value of 4.9. Okay, next one. A forest ranger is in a fire tower 120 feet above the ground. She sights a fire in angle depression, so a different word here, of 3 degrees. How far is the fire from the base of the tower? So let's say here is our tower, and it's 120 feet high. Now, she sees a fire, so the fire might be all the way over here, at an angle of depression of 3. So if this is the forest ranger sitting up here, angle of depression means if this is our horizon, angle of depression means we drop. So this 3 degrees would actually be in there. So let's take a look at how that works. So we said if this is our horizon line, angle of depression would be this thing in here. Okay, I'm going to redraw that fire. And so here is our fire. So when we are looking at our triangle, we have a couple ways to do it. So here's our 3 degrees. So you can either know that, okay, this is definitely going to be a 90-degree angle, so that means this has to be 87 because those two things need to add up to 90. Or what might be easier when we're working with angle of depression is flip this triangle around, connect our triangle this way instead, and then just put our 120 over here instead, and we will not worry about this side. That is how I would do this. If you got a little lost in that, remember, check the lesson and replay what I just said. Okay, we're going to need to make sure we know that. So how far is the fire from the base of the tower? So that would be, how far is the fire from the base of the tower? Remember, she's standing on the tower all the way over here. So that distance, this dotted line, is going to be the same as whatever that is up there. Okay, so we need to solve for this horizontal value because we want to figure out how far that fire is. So this is going to be our x. So what do we know about this? We know that this is our opposite, this is our adjacent, this is our hypotenuse. What is a good fit for us? We're going to definitely have to use tan. So tan of the angle 3 is our opposite, which is 120 over x. We're going to end up flipping those two things. We're going to get x equals 120 over tan 3. Again, we are not solving for our angle. So we get x equals 2289.7, very far away. Okay? From the top of a 38.5 meter cliff, the angle of depression to a boat is 38 degrees. So now I'll show you the other way of doing this. So if here's our cliff, angle of depression to a boat is 38 degrees. So if we are on top of this cliff and we're looking at this boat, the angle of depression is this angle in here. That's 38 degrees. So we can still use this. This is our cliff. We can still use this triangle if we want to, doesn't matter, or we can switch the triangle up and use that way. So either way is going to work. If you want to use this existing triangle we have, we just need to take 90 minus 38 to figure out, well, what is that distance in the gap? And of course, that's going to be 52 for us. Okay? So how far is the boat from the base of the cliff? So I'm going to use this triangle in here. We have to figure out this x value. Okay? So we have tan, again, because this is our opposite, this is our adjacent. You'll find many of our word problems end up using tan. It's probably the most commonly used for word problems. So tan of our angle 52 equals opposite, which is x, over adjacent, which is 38.5. So when we do this, we get both sides multiplied by 38.5. So 38.5 times tan 52 equals x. 38.5 times tan 52 gives us a value of x of 49.2, but it says to the nearest meter, so we're going to leave it as 49. Okay. Now we have a 4-meter long ladder. Here's our ladder. It reaches 3.8 up the side of the garage wall. Find the angle the ladder makes with the ground. So that would be this angle in here. So if we're labeling our triangle, here's our hypotenuse, here's our opposite, here's our adjacent. What do we care about? Well, we only have two values, the hypotenuse and the opposite. So which one uses that? The OH is used by sine, opposite over hypotenuse. So sine of our angle, which we do not know, is opposite, which is 3.8, divided by hypotenuse, which is 4. So when we do the math on this, we can put this right in our calculator, but remember, it's an angle. We need to use -1, okay? So when we do this, we're going to take shift sine -1, 3.8 divided by 4. We get an angle of x of 71.8 degrees. Excellent. It says to the nearest degree, so I should go back and fix that, and we'll change that to 72 because we need to round. Ooh, good one here. Okay, so we have the lighthouse. Oh, I think I didn't assign this one because I'm... 7's a good one. If you feel like doing 7, it's a good one, a good communication style question for you to review those kind of things. Okay? So the next one I believe I assigned for you is 8, 9, 11, and then 10. So 8. Tanya is standing 17 meters from the base of the tower. She measures the angle of elevation. So here's Tanya, 17 meters, and our tower goes up here, and our angle of elevation is 33. What's the height of our tower? This, if we label this, this is our opposite, this is our adjacent, this is our hypotenuse. Which one uses O and A? That is tan. So we're going to use tan 33 equals our opposite, which is x, divided by 17. Multiply that up, and we get x equals 17 times tan 33. Just use your calculator. Don't have to hit shift. Don't have to hit -1 at all. So we're just going to use 17 times tan 33. Gives us a value of 11. Okay, so we get 11. I should put that little degrees sign. Oh, no, I shouldn't. Because we're going to the nearest meter. Okay, so we have 8, we're doing 9. A flagpole casts a shadow 22 meters long with the sun rays, make an angle of 30 degrees with the ground. Okay, it's a good question. So here's our flagpole. That's our flagpole. And it's casting a shadow on the ground. So here's our shadow. And it says the sun's rays, so you can picture the sun's rays, making an angle of 30 degrees with the ground. So here's our ground. So that's where our 30 needs to go. Okay, it says our shadow's 22. How tall is the flagpole? Well, that's our x. So when we go and label this, this is our opposite, this is our adjacent, this is our hypotenuse. So we're definitely going to need to use tan. So tan 30 equals our opposite, which is x, over our adjacent, which is 22. And then we can just multiply that up. X equals 22 times tan 30. So we get 22 times tan 30. X equals 12.7. Excellent. Okay, and then we are 11. So 11 is a bit of a tricky one. This would be a challenge question for sure. Let's try to figure it out here. So we have two buildings. So here are my two buildings. And it says they are 15 meters apart. From the top of the shorter building, the angle of elevation to the top of the taller building is 48. So if we drew a little triangle here, this angle would be 48. And it says the angle of depression to the bottom of the taller building is 34. So now if I look at my angle of depression, this thing is 34. Find the heights of the two buildings to the nearest tenth of a meter. Okay, so let's take a look at these two triangles and what we know about them. So the first triangle we know is 48, and the bottom of it is 15. We're always interested in these values here, our x and our y. And conveniently, if you look at this y value, this height here is also going to be the exact height of this building, which is great. So let's solve for x first, and then we'll worry about solving for y after. So what we're going to do is we're going to take a look. This is our opposite, this is our adjacent, this is our hypotenuse. So we have tan 48 equals our opposite, which is x, divided by our adjacent, which is 15. So we end up with x equals 15 times tan 48. So when we do this on our calculator, 15 times tan 48 gives us a value of 16.6. So we know the short building is 16.6. We still need to figure out how tall is that taller building. Okay? So to figure out the taller building, let's solve for y. This triangle looks like, whoa, this triangle looks like this. This was 15, and this was 34. We need to figure out what y is. Okay? So let's label our triangle, and I'll label it in red. Here's our opposite, here's our adjacent, here's our hypotenuse. And we have tan 34 equals our opposite, which is y, divided by our adjacent, which is 15. Do the exact same thing, and we get y equals 15 times tan 34. And when we go ahead and do that, 15 times tan 34, y is 10.11. So we have that, but that is not the height of our taller building, because the taller building is our y value here, but also plus our x. So we need to add those two things together. So this is our shorter building, but for our tall, we have to take x plus y, so 16.6 plus 10.1, and that's going to give us 26.7. And that is our second answer. Okay, so we're going to write the three trigonomic ratios for the marked angles. This is an easy question to finish off, which is nice. And I'll do it in red. So we're going to look at sine of angle A is opposite over our hypotenuse. And we'll just take it nice and easy. We're not even going to solve for that other side. We're just going to say it's 8 divided by whatever our hypotenuse is, which is line AC. Our cosine for A is, I should label this triangle, adjacent divided by hypotenuse, which is 15 divided by AC. And our tan for angle A is just opposite over adjacent, 8 divided by 15. Okay, our next one, if we're looking at it from this angle, this is our hypotenuse, this is our opposite, this is our adjacent. So our sine of E is our opposite over hypotenuse, which is 16 divided by our hypotenuse, which is EF. Cosine of E is our adjacent, which is 12 divided by EF, and then our tan of E, which is opposite over adjacent, which is just 16 over 12. And that is solutions for number 5 done.